Finding the points of intersection with the axes and the turning point of the curve provide all the information needed to make a sketch. Start by sketching the axes. Any intersection with the x-axis occurs when y equals 0, and when y equals 0, 2x squared minus 5x minus 3 equals 0. Using the quadratic formula, since the equation does not factorise easily, compare the general equation with 2x squared minus 5x minus 3 equal to 0 to determine the values of a, b and c. Comparing the coefficients gives a equal to 2, b equal to minus 5 and c equal to minus 3. These values are substituted into the formula, where brackets are also used for clarity. Substitute b equal to negative 5 in the first term. Include brackets with a minus outside. Then substitute for b in b squared. Include brackets with a square outside. Substitute for a and c in the term for ac, also including brackets. And finally substitute for a in the denominator. Note that it is the whole of the numerator which is divided by the denominator. Now working with the negatives, minus negative 5 can be thought of as minus 1 times minus 5. Two negative numbers multiplied together give a positive number. So this results in positive 5. Negative 5 all squared is the same as negative 5 times negative 5. Again, two negative numbers multiplied give a positive, giving positive 25. And working out the bracket gives negative 24, giving the square root of 25 minus negative 24. And finally, the denominator gives 4. Minus negative 24 can be thought of as minus 1 times minus 24, giving plus 24, since two negative numbers multiplied together give a positive number. So now x equals 5 plus or minus the square root of 25 plus 24, all divided by 4, where the square root can be simplified to the square root of 49, which is equal to 7. So one value of x is 5 plus 7, all divided by 4, which is 3. And another value of x is 5 minus 7, all divided by 4, which is negative 0.5. Giving the points of intersection with the x-axis as 3, 0 and negative 0.5, 0, which are plotted on the sketch. The quadratic curve passing through these points could look like this, or this, or maybe like this, or this. In order to find which curve, we need to find the point of intersection with the y-axis. The curve cuts the y-axis when x equals 0, so substitute x equal to 0 into the quadratic equation. Any term containing 0 gives 0. Therefore y equals negative 3, giving the point of intersection as 0, negative 3. Plotting this point on the sketch enables the correct graph to be drawn. This could be sufficient for a sketch, but you may want to find the turning point. All quadratic curves have a line of symmetry, which also indicate the turning point of the curve. The line of symmetry is midway between the points of intersection on the x-axis, that is, between negative 0.5 and 3. So adding these two values and dividing by 2 gives 1.25. So halfway is 1.25, giving the x-coordinate of the turning point as 1.25. To find the y-coordinate, substitute x equal to 1.25 into the equation. Use brackets to ensure it is only 1.25, which is squared. Completing any multiplication first, then any addition or subtraction to obtain negative 6.125. So the turning point is 1.25, negative 6.125. We say it is a minimum turning point because the curve does not extend below it. Finally, adding the equation of the curve completes the sketch. In this video, b squared is greater than 4ac, and so gives a positive square root, which can be evaluated to give 2 points of intersection on the x-axis.